So here we have a worksheet just on working on derivatives of logarithms and exponential functions once more. So this is not quite like we did with ln, so it's just kind of a step above. And keep in mind, these are not my worksheets. My worksheets, we know when I label them Morrissey up top. So this is one that I pulled from the internet. I really liked whoever created this because it has lots of variety. I like the question type itself, as well as the answer key. So here's the answer key. So hopefully you've paused the video and want to show what they have at the end. Otherwise, let's go ahead and take a look. Now, these first few are ones that we did in our previous lecture where we talked about these derivatives. Now we get to take a look at some of these more in depth. So we'll start here where we have the derivative of an exponential function, an exponential without the idea of e. Now, keep in mind what we talked about in that previous lecture on how we got the derivative and why it looks like this, right? But the derivative is just saying, hey, we are going to take the natural log of a. This is your base here. So we're going to say the ln of a times itself times the derivative of the exponent. So to start us off, right, we take the ln of your base. That base for us is going to be 6 here. Let me go ahead and highlight that 6. Then we get to write itself 6 to the 3x minus 4. And then we get to chain rule it with the derivative of the exponent, that being 3. And no, we cannot just combine 6 times 3 to make 18, because keep in mind, this is going to be a number once we select x, as well as ln of 6, this is also a number. So if I were to write it out, I would do something like 3 ln of 6 times 6 to the 3x minus 4. That's as far as we could go with simplifying that one. So let's try it again in 42. Now 42, we're giving it a step up with pairing what we just learned with the product rule. Recall the product rule as being f prime of x, g of x, plus f of x, g prime of x. All it's doing is each one is taking the turn of getting the derivative. So let's go ahead and break these up if you need. That first function we'll just call x and derive it. This second function we'll call g. This is 6 negative 2x. And let's go ahead and derive that. Now keep in mind, we have your base here. This is 6. So just as we did it before, we want the ln of your base times itself times the chain rule. So all together, we have negative 2 ln of 6 times 6 to the negative 2. Now you might have teachers that with this on the outside, they might want to have you use your properties of logarithms, but it's up to what your teachers have told you how they want you to orient it. So for us, right, when we put it all together, we have the derivative of f prime. So my derivative of f, that is 1, times g, that is this whole thing here, 6 negative 2x, plus f of x, that is just here, x, times the derivative of the remaining. Sorry, I forgot to highlight here. Oops, one more. Negative 2 ln of 6 to the 6 negative 2x. So what I might do also is see if I can take out what they have in common. So for us, we have this 6 to the negative 2x in common, leaving behind a 1 minus 2x ln of 6. Now I'm just going to take a look and see exactly what your answer key, how they oriented your question. Yeah, no, they left it. Let's see, where else am I? Yeah, they kind of left it. They haven't simplified all the way, but that's okay. Okay. We'll do a few more. So let's see, let's journey into your logarithmic functions. So here, let's see, let's do this one. Now, keep in mind when we talk about a logarithm specifically, right? ln is a logarithm. That's why we get to use the property of this ln here. It's just in a different orientation. Keep in mind, ln has a base of e. Log itself has a base of 10. And if we have log base a, this has a base of a, whatever that value is. So when it comes to our derivative of a logarithm, we're going to be using the ln of a. So the base we have here. So again, we do 1 over, that is the aspect from your natural log or your logarithmic derivative, over, again, this value here of itself. Kind of just highlight to keep a track. And then your derivative of the inside function. So derive the inside. This is itself. This is your base. So let's put that all together here on something like this one. So first, right, we have 1 over the ln of your base. Our base is 3 times itself, and I think I used this color here, x squared minus 3x. And now chain rule it. Let's go ahead and derive x squared minus 3. Well, that would be 2x minus 3, and we can put it all together over here. 2x minus 3 all over ln of 3 times x squared minus 3x. Now, I'm not sure if your answer key has simplified a little bit more with these two x values here. If they've taken it out, I'm going to take a sneak peek. 48. No, they haven't. They just kind of left it as is. So that's what we'll do here. All right, let's try it again with 51. Now 51, I'm going to rewrite to show that we have the power of 1/2. So let's go ahead and do 1 over the ln of your base. That base is 5 times everything over here. Now we get to chain rule it. So chain rule, right? We have 1/2 of x squared minus 1, now to the negative 1/2. And keep going. Now we have 2x. Now what's nice is that if we have half of 2, that is just itself, so that will cancel. So altogether we have 1 over ln of 5 square root of x squared minus 1. We also have another one, the square root of x squared minus 1. We also have the x that's up here. Now notice that you have these two of them. So that will combine and duplicate it. So we have the duplicated amount. So we have x squared, we have x over ln of 5 times x squared minus 1. And I'm going to sneak peek and make sure that we did that. Perfect. Oh, and you'll notice that for them, they chose to do the properties of logs first. So they chose to put this 1/2 in front and then derive as they normally would. You'll notice that we got there in the end no matter what you kind of start with. So if you don't recognize or if you're not familiar with your properties, I just wasn't thinking, which again, you get there either way. You just have to know what you're looking for. So let's do their method now that I know what their setup is. They're going to bring their 3 down in front of your logarithm. And this is just using the property of logarithm. So we're not, in fact, using your derivative quite yet, right? We're just going to put it right in front. And now what we're going to do is we're going to keep this out here and then derive this inside portion here. So you have 1 over ln of 2, and then itself, t squared plus 7. Now chain rule it with 2t. And keep in mind, we still have that 3 here. So altogether, we have 6t over ln of 2, t squared plus 7. Again, sneak peek here. And then you have it. Again, you could also do it in the same approach that we did, just keeping everything the same. It will just have you simplify a little bit further. It will end up being that you get to cancel out some of these t squares plus 7s. And I think I showed that in one of my examples earlier somewhere. I think this one over here. You'll notice that I didn't put the 2 in front. Instead, we derived as normal, use your chain rule here, and then we got to cancel out some extras. I'll complete maybe one more. Maybe complete this one. You'll notice that this 2 on the bottom, this is just really a 1/2 out here. So we have log 3 of 1/2 times x square root of x minus 1. Actually, even better. So this is 1/2 x. There you go. Now here, if you want to, you can use the properties of logarithms here as well. Yeah, you can do that with any of them here and here, which actually I might do 53 with that being said, because we haven't seen something like that in a while. So let's do that instead. So this division sign, we are going to make into a subtraction. So we have log 2 x squared minus log 2 of x minus 1 here. Again, we're just going to break these 2 up into its own separate logarithms, just like you did with properties of natural log. We can use that to our advantage. And again, if you want to, not a big deal, but you can, if you want, put that 2 down in front before you get to derive. And now you get to derive in parts. So here we have your 2 that kind of remains times 1 over ln of 2, that comes from this portion here, times x, and then chain rule it, that would just be itself, minus 1 over ln of 2, your base, times x minus 1, chain rule it, times 1. So all together, we should have 2 over ln of 2x minus 1 over ln of 2 x minus 1. And I believe that's as simple as they wanted yours to be. Yeah, they kept it as is. Oops, I did actually make a mistake. Nope, no mistake. So sorry, they just didn't simplify. They didn't cancel this 2 with that x. Well, I thought they would have went all the way over there. That's okay. But that's pretty much what kind of entails with your derivative of logarithms and just exponential functions.